Hi there, today's topic is matrix, in which we will deal Cramar's rule. For example, the equation is given as, just write down the equation: 3x1 plus x2 minus x3 equals to 5, x1 plus 4x2 plus 2x3 equals to 6, and 2x1 plus 3x2 plus x3 equals to 4. For this equation, we can solve like ax equals to b. Take the values as, make a matrix, that is, this will be 3x1 3, x2's value is not given, so it's 1, then minus 1 1 4 2 2 3 and 1, and the given x is x1 x2 and x3. Simultaneously, for b equals to, b will be, these are the values 5 6 and 4. Just put it over here, 5 6 and 4, and we have generalized the equation. Now we are solving this. Firstly, take the determinant of it. The determinant of a equals to 3 and take its submatrix. This is by deleting 3's row and 3's column. This is 4 2 3 1. Write it over here, 4 2 3 1, and now then afterwards we shall make cross multiplication of it. Then it's minus 1 by deleting 1's row and 1's column. That will be 1 2 2 1 plus minus 1. This will become minus 1 as plus minus minus. Then it will be by deleting the row and column. It will be 1 4 2 3, 1 4 2 and 3. Let's solve this. Equals to 3. Make a cross multiplication. 4 1's are 4 minus 3 2's are 6, minus 1 1 1's are 1 minus 2 2's are 4, minus 1 again, 3 1's are 3 minus 2 4 2's are 8, equals to 3, and that will be minus 2 minus 1, that will be minus 3, then again minus 1, this will be minus 5, equals to 6 minus 3 1's are 3 minus minus plus, this will be 3, 5 1's are 5 minus minus plus, and that will be 5, equals to that will be 2. So we got the value a determinant equals to 2. I'm circling it out as a determinant is 2. Then afterwards we have to find a1 determinant. Take the same equation, a1 determinant. A1 determinant can be found as For A1 determinant, we put value of B into first column of A and writing it out as, making it a simplified version, like it will be 5 6 4. Just see over here. Wait a minute. I'm taking this column and putting it over here, so it will be 1 4 and 3, then again -1 2 and 1. Now we can get the A1 determinant, and we are taking the A1. We can get the value of A1 as taking the determinant in the same proportion, like it will be first by deleting its row and column, that will be 5. Take its submatrix, that is 4 2 3 and 1, then -1, again 6 2 4 and 1, then again plus minus minus 2, that is plus, where we are putting value plus, and plus minus -1 is -1, and it is 6 4 4 3. Let's solve this again. Equals to 5 -1 -1 again equals to 5 -2 -1 again, -2 -1, and its value, that is 2. 18 minus 16 is 2, equals to that is -10 plus 2 minus 2 equals to -10, and we got A1 determinant as -10. I'm again circling it out. This is A1 determinant is -10. Then to find A2 determinant, we put B into second column of A and making a matrix, that will be, take the values please. The value is 3 1 2 and 5 6 4, again -1 2 and 1, and get A2 determinant equals to again 3 by deleting the same row and same column, that is 3, and its submatrix is 6 2 4 1 -5 1 2 2 1 plus minus minus -1, again the value is 1 6 2 and 4 equals to 3 -5 -1 equals to 3. Again inside is -2, again -5, inside is -3, -1, inside is -8, equals to minus 6 plus 15 plus 8, we can get the value. The value is 17 and it's a positive 17. So A2 determinant is 17. Then again we have to find the value of A3 determinant. To find A3 determinant, we put B into third column of A and making a matrix, that is 3 1 2 1 4 3 5 6 and 4. Let's do A3 determinant equals to again 3 4 6 3 4 minus 1 1 6 2 4 plus 5 1 4 2 3 equals to 3 I'm solving it out, you must have to solve as well. Minus 1 equals to minus 6 plus 8 minus 25 equals to minus 31 plus 8. That is minus 23. So we got the value minus 23. I'm again circling it out as A3 determinant is minus 23. For getting the value of x, y and z, we can work out like this. By Cramar's rule, the value of x1 equals to a1 determinant oblique a determinant. Put the values as we got the value for a1 determinant is minus 10 and a determinant is 2 equals to minus 5. Simultaneously for x2 equals to a2 determinant oblique a determinant. This is as we got the value of a2 determinant is 17 oblique 2 equals to 8.5 and x3 equals to a3 determinant oblique a determinant equals to we got the value of a3 determinant as minus 23 and a determinant is 2. Again 11.5. So the henceforth the value of x1 equals to minus 5, x2 equals to 8.5 and x3 equals to 11.5 and Cramer rule is solved as 11.5 is of minus. Just put minus over here. This is minus 11.5, right? I'm circling it out. So these are the values of x1, x2 and x3 and the Cramer rule is solved for the matrix 3 by 3. Thank you.